Good morning, everyone. Today we are going to take a closer look at planning and system installation. This lesson can be found under System Fundamentals and System in Organizations. As in this lesson, the whole lesson will be covering planning and system installation. We will first start out by finding the context for which a new system is actually planned. In most cases, a system is proposed because the current one is either inefficient, outdated, or no longer appropriate for the original purpose. A new system, although, can also be implemented to maximize productivity, quality, or reduce costs. Next, we have the need for change management. Change management is probably a term we never heard of, but it's probably very important. If you just build a new system, you don't really know how your users or your staff is going to react, if they are going to like it or not. And it's important to help them go through this time because, well, users don't really like changes in most cases. A new system might also omit old features. People also find change complex, and from a technological perspective, change might lead to incompatibility. So, change management is the process of transitioning individuals, teams, and departments from a present state to a desired state. In our case, the present state would be our old system, and the desired state, our brand new system. So, the purpose for change management would be to implement strategies to help people to adapt to this new change, this new system. Nice. Next, we have different system implementations. We'll really only have like two competing ways of implementing systems, and they are either local or remote on the cloud, a cloud-based implementation. The local system is pretty straightforward. We have a computer, and our application logic runs solely on that computer. This is great for big organizations that want to manage everything, so they would buy several servers and manage everything. But if we are maybe smaller and we don't want really to buy dozens of servers, we maybe only want to run our application logic in the cloud, a third party doing it. And this is called, well, we know it maybe cloud-based, but it's also called SaaS. SaaS stands short for Software as a Service. And this is a software distribution model in which a third-party provider hosts the application and makes them available to customers on the internet. So they host our application, our system in their computers, and we don't need computers in our organization. Some very well-known SaaS examples would be Microsoft Office 365, formerly known as Office 2016, which was local. We needed to download Office in our computer, we needed to download Word. Now, Microsoft Office 365, we can still download it, but we can use it on our web browser. Also, Google Apps, we don't need to download Google. We don't need to download Google Maps. It's solely on the cloud. It's a software that we use as a service. Now, benefits and drawbacks of this implementation. So benefits would be a really low initial cost for the organization because, well, they don't need to buy extra computers to run their logic. It's also easy to upgrade, easily accessible from anywhere as it is on the cloud. It's also easy to predict the cost because it's subscription based. For example, Netflix is a SaaS product, and you pay every month $10 for Netflix, and next month you are going to pay $10, and so on and so on and so on. So it's easy to predict. The application is also ready to be used. Now, some drawbacks, disadvantages of this implementation. Well, the most noticeable is probably that we are completely dependent on the third party. If our third-party provider just shuts down, we go with them. Another would be security and confidentiality. And another big one, we are completely dependent on the internet. If we offer a product to the public, they only can use it when connected to the internet. We have a risk of data loss. Again, if the third party shuts down, we will probably lose our data. And it's not as powerful as maybe buying the servers and managing them on our own. Now, going to alternative installation processes. We now have our system ready and we want to make it work in our organization. There are different installation processes. Probably the most simpler one is just to stop this old one and make the new one starting to work. It's pretty simple, but probably not the best one for most occasions. Some advantages of this is it's minimal time and effort. We just plug one out and plug the other one in, and the new system is available immediately. Now, the biggest disadvantages is if the new system fails, there is no fallback. Meaning, well, if our new system has bugs and it shuts down, there is nothing to be used by our users. And well, this picture illustrates it pretty good. We have our old system, we are this red line, we come in, shut it down, and the new system starts to work. Very simple, but it also has a huge drawback. Another alternative installation process would be the parallel running. This is when the new system is started, but the old system is kept running alongside it. Data has to enter in both systems. This solves some problems the other one has. For example, this as an advantage as if the new system fails, the old one runs as a backup. In this illustration here, we are the red line again, we come in, the old system runs, but the new system also runs. So if this fails, there's still the old system. And outputs from the two systems can be compared to check if the new one is working correctly. And the biggest disadvantage is not that big is compared to the other one, but it will be more costly in terms of time and money. We now have two systems we have to take care of. It will be significantly higher in terms of money. Another one would be the pilot running. This is when the new system is piloted, tested with a small subset of the organization. Once it is running correctly and all bugs have been fixed, it is implemented across the whole organization. So we only use a subset of the organization, make it work there, and then put it and just then substitute the whole system with the new one. Advantages: all features are fully tested. If the new system fails, only a small part of the organization suffers. That's pretty good. And as a disadvantage, for the subset of users in the pilot group, there's no backup if the system fails. That's, yeah. Then, last, we have the phased conversion. This is when the new system is introduced in phases as part of the old system and gradually being replaced by the new system. Advantages: allows users to get used to the new system, and training of staff can be done in stages. So this is really in phases. We also see it here. It's been done in phases, and if the new system fails as a disadvantage, there is no fallback for that part of the system. These are the 4 alternative installation processes. Now, problems that may arise as part of data migration. Data migration is just another word for moving data around, and it can be migrating data can be as simple as putting a file on a USB drive and opening it on another computer, or really as complex as exchanging information through big databases across different countries with different time zones. So, nevertheless, this following problems may arise: incompatible file formats, data structure differences, incomplete data transfers. So if the data transfer doesn't complete and it's interrupted, the whole file is lost. And international conventions on dates, currencies, and character sets. For example, in the UK, this date is recognized as 3rd May of 2019, but in the US, it's recognized as the 5th of March. So just some things to keep in mind which can happen in the process of data migration. And finally, we have the various types of testing. We now have our new system up and running, and we want to test it if it's, well, working fine. So testing is a really crucial part when developing a computerized system, as it tries to ensure that the system works as expected. If a system does not work as expected, for example, it contains bugs, the productivity and end user satisfaction will be drastically reduced. So to ensure that the application runs smoothly, here are different types of testing. First, we have the alpha testing, which is completed by the employees working on the product. So the developers would test the product. Beta testing is probably something we know, and it is when the application is tested by the users, not the employees, just users that use the application before it's completely public to the general public, and they just give feedback. Then, next we have the dry run testing. This is a testing made by the programmer, and he just writes the algorithm using a pen and paper and goes through the algorithm through his head and thinks what the output should look like. Unit testing is when we test only small parts of our algorithm, of our system, and see if they are working. In contrast, we have the integration testing. Integration testing is testing everything at once to see if everything works together. And the user acceptance testing is to see if our application really meets the expectations of our end users. And I know this lesson was pretty fast. It's some content we need to take care of, and I wanted to go fast through it. Otherwise, the video would be really long. But we always have the study guide in Happy Grind, so make sure if you don't understand any something, just check out there or just send me a message. Yes, here are the resources I used, and I hoped I helped you in some way. Bye bye.